Good afternoon.
Good afternoon.
As I told you, I will do a lecture for 30 minutes, and then you will take which problem will be pretty easy as long as you study. And tomorrow, as I told you, we will not meet here, but I will give a Zoom lecture and I will record and post it, so you don't have to attend a live Zoom lecture tomorrow, but you have to watch it. Okay? Last time we started the volume with this class method. The formula is like this: when we think about the volume of the object made by rotating around the x-axis, and then the object will look something like this, three-dimensional object. I have to put it down. But anyway, so we will just like dissect the object like this, and then we will have cylinder that yes, a cylinder, and then this area is this, right? This area with the radius of function value, right? And so the formula comes out to be pi r squared, so pi f of x squared times this thickness, height of the cylinder. So what we want to do is we want to consider the function y equals x squared over 2 plus 2. And we want to think about the region surrounded by f of x and x-axis, x equals -1 and x equals to 1. We rotate around x-axis. So what's going on here is we have a problem like this, and then we want to rotate that problem along x-axis, and then the object we will obtain will look like this. And this one is a -1, and this is 1. And we rotate the object, and we're dissecting the object in this way. So what you can imagine is cylinder that looks like this. And then this time the function is given as f of x equals x squared over two plus two. So what is this r? R is x squared over two plus two defined by the function. And then this thickness will be the height of the cylinder. And when we integrate, that will become like dx. And what we are thinking about is from here to here, indeed. We think about this part of the object. So we have to think about integration -1 to 1 times r squared, so this area, that is x squared over two plus two squared dx. So that can be written as pi -1 to 1 x to the fourth power over 4 plus 2 times x squared over 2 times 2 plus 4 dx. So what is this part? These two will cancel each other, and this one is 2x squared. So that is pi times 1 over 4 from here, x to the fifth power over 5 plus 2 from here times x cubed over 3 plus 4x from -1 to 1. And then I believe everybody can proceed with the calculation by plugging in 1 and subtracting -1 after you plug in. There's 283 pi over 13. Yeah.
Would you the same method if you were to rotate this object around the y-axis instead?
If you rotate the object along y-axis, then cylindrical object would look like this, right? The thickness would be delta y, right? And so we will think about the y region, and then the function we have to deal with will be defined with y, right?
Okay.
Yeah.
Thank you.
Any other questions? Later, we will see the example like that. The next problem is f of x equals -2 equals -x. And we think about x-axis. X equals to 0 and x equals to 1 rotated around x-axis. Our review is how does the function look like? So y equals e to the x look like this. And y equals e to the negative x will flip along y-axis. So it will look like this, right? And then we want to figure out how the function f of x equals -2 times e to the negative x look like. So it is like, equally negative x, right? And then there is minus sign here, so we have to flip along x-axis. So this is the graph of y equals f of x. So this time we will draw a cylinder that looks like this. And this R is f of value of this one. So R equals f of value of f of x, right? So that means that is 2 times e to the negative x. And then the area of this part is pi r squared, which is pi times 2 e to the negative x squared. So that is 4 pi e to the negative 2x, right? And then this thickness can be interpreted as dx, right? Because it's in x. So volume will be integration 0 to 1, because we are thinking about 0 to 1. Pi r squared, so that is 4 pi into the negative 2x and dx. So that is 4 pi integration 0 to 1 e to the negative 2x dx. So what should I do? You have to use substitution you learned. And that's in the quiz range. So u is negative 2x. And then du equals negative 2 dx. Therefore, dx equals negative 1 over 2 du. So when x equals 0, u equals negative 2 times 0 equals 0. If x equals 1, then u equals negative 2 times 1, which is negative 2. So we are doing a change of variable. So we will change the region, upper bound and lower bound to 0 to negative 2 and e to the u times negative 1 over 2 du. Right? So this one is 4 pi times negative 1 over 2 times integration of e to the u is e to the u from 0 to negative 2. So what is this? This one is negative 2 pi e to the negative 2 minus e to the 0. What do I end up with? Negative 2 pi times e to the negative 2 minus 1. So I will continue with volume with the lecture method. F of x equals x and v of x equals x to x squared over 4 between x equals 1 and x equals 2. Rotated around x-axis. This time we are thinking about one more function. Let's draw the picture first. One parabola. Field x equals x squared over 4. And this is y equals x. And we want to think about the region x equals 1 and 2. And we are rotating around x-axis like this. But this time the difference, so we are thinking about this region, this dotted region. And we rotate around the x-axis and then two curves are involved. So, what happens? We have a larger circle from this one, and we have smaller circle here. So what happens here is the outer circle radius is defined by y equals x, and so that is x. And for this one is inner circle. That is x squared over 4. Right. And so what's happening here is when we think about the object, that will have a hole right in the middle, right? So after we calculate rotation of this y equals x, we have to subtract the rotation of this part because that is the inner cylinder that we have to eliminate. So what I will do will be 1 to 2 pi r squared. Again, this one is a dx, right? The x region is from 1 to 2 pi r squared will be the outer circles squared minus inner circles of radius squared dx. So that is from 1 to 2 pi times 1 to 2 f of x. This one is the f of x. That is x squared minus x squared over 4 squared dx. So that is pi integration 1 to 2 x squared minus x to the 4th power over 16 dx. So that is pi times x cubed over 3 minus 1 over 16 times x to the 5th power over pi 1 to 2. And then Do you have any questions so far? No questions? And then you will plug in two, and then subtract, one after you plug in one. And then you will keep going with algebra. Then you have to get 467 times over 214. So now I wanna do, one more problem, and then you will take a quiz. The next problem is u of y equals y 3 over 2, and v of y equals y 15, y equals 1, and y equals 3. This time we think about rotated around the y-axis. This time we rotate around the y-axis. This is v of y equals y. And the graph of y to the 3 over 2 looks like this. Actually, I have to go a lot longer anyway, so it, it maybe, looks like this. And then this time, what we wanna do is we wanna, rotate along y-axis. So when we draw the cylinder, the stick we are, thinking about is this one, and then we will just rotate along y-axis, right? And so this time we think about delta y, so that will become dy. So instead of stick vertically raised, this time it is horizontally raised and then go around y-axis. So what can we say about this? So we think about this one and this one. This one is larger, larger x value. And this one is a smaller. The difference between the previous one and this one is this size. We're thinking about the larger and smaller x value instead of we think about the larger and smaller y value. Because we are rotating around x-axis. Or y-axis. So v of y will become y ranges between 1, 2, 3, 5 times v of this one is the u of y, right? U of y plus y it is 3/2. So u of y squared minus v of y squared dy, right? Because of u of y is smaller. And then what is that? That's 5 times 1, 2, 3. U(y) is y 3/2 squared minus u of y is y squared dy. So this one is 5 times integration 1, 2, 3. Y2 minus y squared dy. So that is 5 times, what is that? Y to the fourth power over 4 minus y2/3 from 1 to 3. So we keep on going and going like that, and then you have to get 34 pi/3. So we are thinking about this region, and we rotate around the y-axis, so we draw the shape like this, perpendicular to y-axis. So we are thinking about perpendicular y-axis, and then if we rotate around the x-axis, then when you draw the stick to dissect the region, that must be perpendicular to x-axis. So in tomorrow, you will learn about the cylindrical snow method. Then it will be, when you draw the stick, you have to draw the parallel to the rotational axis. And formula will be different. So that's it for today. I will have to cover 2 more examples tomorrow, and then we will talk about the cylindrical shell method. So I will be this now. So that we can get the next year.